Hi everyone, this is Mrs. Eggerding and you're watching video 5 of our last unit, and we're going to talk about graphing a conic section called a hyperbola. And one of the things we're going to have to talk about is how to distinguish between a hyperbola and an ellipse. Before we begin though, I want to talk about what is a hyperbola. And we'll get into a little bit more detail in class, but if you can imagine you have two axes and you do have a center point, and then you have two vertices. Okay? You also have some asymptotes that go through the center. Okay? The hyperbola will ride along those asymptotes, touch the vertex, and then continue riding along the asymptotes. So it rides along the asymptotes, touches the vertex, rides along the asymptotes again. These vertices are on, instead of calling things a major and a minor axis, these things on the vertices here, this is called a transverse axis. And this transverse axis can be horizontal, like I made it here, or it could be vertical. And if it would be vertical, you'd have your center point, you'd have two vertices, you have asymptotes that go through the center, and then your graph would ride along those asymptotes, pass through the vertex, ride along the asymptotes, pass through the vertex. And in this case, your transverse axis is this one going up and down. And so our job today is going to be to look at an equation, be able to distinguish which way it opens, if it opens left to right or side to side. This is what I call a left-right opening or side to side. This one is the up-down opening. So we're going to, from the equation, figure out which one is which, find the center, find these vertices, and then get a start into how do we graph those asymptotes. Okay? So, equations of a hyperbola, two different forms, and the one thing I want to point out first of all is on a hyperbola, this middle sign is a subtraction sign. On an ellipse, it was a plus sign. So here on a hyperbola, it's a negative sign. Distinguishing the left-right and the up-down comes from what comes first. So when this x term comes first, that's going to open left-right. Or sorry, I should say when the x is positive. So the x squared term here is positive. Opening up and down, you have the y squared term being positive. As far as the center it works the same for both of these. The center is HK. The only thing you have to worry about is when the y squared term is positive, you do have to be careful where that comes from. The vertices. The vertices always go with the positive axis. Okay? So if it opens left to right, this a term will be the vertex. If it opens up and down, the a squared term gets you the vertices. So a is going to be the distance from the center to a vertex, and it will always be on that transverse axis. Okay? The B term does come into play, and we're going to use that to help find our asymptotes. So there's the beginning of it. Let me show you what it looks like in action. So here is our hyperbola, the first one. X squared over 16 minus y squared over 36 equals 1. I know it's a hyperbola because I have this minus sign in the middle. My center is at 0, 0. I'm also going to make a note of which way this one opens. My x squared term is positive, so this one is going to open left, right. Okay, so I'm going to draw my center at 0, 0. Underneath the x squared is 16. So my A is 4. Since it's going left and right, that means I'm going to go 4 left and 4 right. And those are going to be my vertices. Negative 4, 0 and positive 4, 0. Okay? Now this 36, that does tell me I have a B value of 6. Because it's under y, I am going to go up and down 6. But these aren't vertices, and these are not part of our hyperbola. What the 6 up and down does is it allows me to make a rectangle. And these points that I made, both my vertices and these points on the y-axis, act as midpoints of a rectangle. The asymptotes are the diagonals of this rectangle. The asymptotes are diagonals of this rectangle. And so you do want to draw those in. I'm going to go with the blue again. Goes through the center and through the corners of the rectangle, or the diagonals. Will go through the center. Those are your asymptotes. Now when I go to graph this, I'm going to go side to side, so I'm going to ride along the asymptote, come and hit my vertex, and go along the asymptote. Do the same thing on the other side. Ride along the asymptote, hit the vertex, ride along the asymptote. Okay? Center, just like everything else, you need to decide which way it opens. Vertices, the vertices will always be on the direction it opens. The other value, in this case the 6, helps us form a rectangle so I can draw in my asymptotes. Let's take a look at one more of these. Okay, this time it's going to be off center, so this time my center is going to be at 1, negative 5. This one opens because the y is positive. This one is going to open up and down. So let's graph the 1, negative 5 as my center. My A value here is 3. So my vertices are going to be up and down, because that's the way it opens. 3. 1, 2, 3. There's a vertice. Down. 1, 2, 3 from the center. There's a vertice. So it's going to be at 1, negative 2 and 1, negative 8. My B value is 2. So I'm going to go side to side, or left and right 2. 1, 2. 1, 2. Using that, now I'm going to draw my rectangle and the asymptotes, which are the diagonals of the rectangle. So my rectangle, the vertices and these other dots are the midpoints of them. Use the horizontal and vertical lines. draw in the asymptote through the center and the diagonal of the rectangle. This one opens up and down, so I'm going to have to use the vertex here, right along the asymptote, hit the vertex, right along the asymptote. Right along the asymptote, hit the vertex, right along that asymptote. And there is the graph of that hyperbola. Now feel free to go back and look at this again. We are going to talk more about this in class. We're going to talk more about the asymptotes. There are foci with these, so we will have to talk about the foci, and we'll talk about this transverse axis a little bit more in class. We just wanted to get you a feel for some of the basics. So on page 608, questions 1 through 4, they just ask you to tell the difference between an ellipse and a hyperbola. 7, 9, and 19 are ones for you to graph. And you just need to worry about identifying the center, identifying the vertices, and then sketching a graph with that rectangle and the asymptotes. There is an entrance slip that asks you to do some similar things. And 2 things you should be able to do. 1, be able to distinguish between an ellipse and a hyperbola, both on the graph and from an equation. So from the graph or from an equation. And then the second thing you should be able to do is graph a basic hyperbola. We will see you in class. Good luck with this and take your time. So long.